Okay, today is the first day of solving trigonometric equations. To solve the equation, we want to use the algebraic principles. We want to combine like terms, possibly factor, and then solve for the trig function. As with any solving, we want to isolate the variable. So in this case, we would add 1 to both sides. And then I have 2 sine of x equal to 1. Again, this is what I'm trying to isolate, the sine of x. Then I divide both sides by 2, and I have that the sine of x is equal to 1/2. So then I go back and I think about my unit circle, and I say sine is a y value. Okay, so I want to go to 1/2 right here. So what are these angles to which the sine of an angle is equal to 1/2? And then you say, oh, okay, so x could equal pi over 6, and x could equal 5 pi over 6. Okay, so now, since I'm solving, how many times or how many different angles could I actually put there that would give me a sine value of 1/2? Well, every time I go around the circle, I will also get that. So if this is pi over 6, then at 13 pi over 6, this is also an answer, 13 pi over 6. Also at 25 pi over 6. So I can do pi over 6 plus 2n pi. And same is true for 5 pi over 6. I will get this exact same value every 2n pi. And correct that n is going to be an element of the integers here. Now, as long as you state this once, you could just get away with one of these. But remember that the natural period for sine cosine is 2 pi. So I will get back to that very same thing every 2 pi. These are what we call general solutions. Okay, so, or all solutions. But there are times where we can actually just focus on a certain range. So this says we want to find solutions from 0 to 2 pi. Those are restrictions. So let's just assume that we're going from 0 to 2 pi for these right here. Again, I want to isolate the variables. So I'll subtract 1, and the sine of x is equal to -1. So if I look at my unit circle, when is the sine value -1? I actually only have one solution there. So that would be x equals 3 pi over 2. Again, if I'm just talking from 0 to 2 pi, then I only want that one solution of 3 pi over 2. If I'm looking for the general solutions, then it would be 3 pi over 2 plus 2n pi, where n is an element of the integers. Okay, so these are restricted, and these are all solutions. Okay. Next one here, I add 1 to both sides. I get 2 cosine of x is equal to a +1. Divide by 2. So I get that the cosine of x is equal to 1/2. So I think back to my unit circle. Cosine is an x value. So right here, when is that cosine a +1/2? And it looks like it'll be in two places. This is going to be pi over 3, and this will be 5 pi over 3. So x is going to be pi over 3 and 5 pi over 3. Or I could write the all solutions as x being pi over 3 plus 2n pi, and x is also 5 pi over 3 plus 2n pi, where n is an element of the integers. Okay, so these are restricted, and these are all solutions. Okay, example 4. In this case, I have sine of x plus square root of 2 equals negative sine of x. I'm going to add sine of x here, and I'll get 2 sine of x plus the square root of 2 is equal to 0. All right, when I subtract the square root of 2, I get 2 sine of x is equal to a negative square root of 2. Divide by 2, and I have that the sine of x is equal to a negative square root of 2 over 2. So I think about my unit circle. Negative square root of 2 over 2 is about right here. These are our pi over 4 families. So this will actually be 7 pi over 4, and this would be 5 pi over 4. So my solutions here would be 5 pi over 4 and 7 pi over 4. If I had to write the equations, again, it would be those plus 2n pi. All right, here's another one. I'm going to add the sine. I'll end up with 2 sine of x minus the square root of 2 equals 0. Add the square root of 2, divide by 2, and I end up with sine of x is equal to the square root of 2 over 2. And that's going to be a positive, so this would be a pi over 4 and then a 3 pi over 4. Again, these are my restricted solutions. If I want all the solutions, then I would just add 2n pi to each one of those. Okay, now I have a cosine. I'm going to add the cosine. I'll have 2 cosine of x minus the square root of 3 equals 0. Then I'll have 2 cosine of x is equal, I have to add that, so a positive square root of 3, divide through by 2, and I have cosine of x is equal to the square root of 3 over 2. Well, remember, cosine is my x values, so I want a positive square root of 3 over 2, which puts them like right here. That's going to be a pi over 6, and this will be 11 pi over 6. So those are my solutions here. Pi over 6 and 11 pi over 6. Again, I can write those equations. So they would look like x equals pi over 6 plus 2n pi, and x equals 11 pi over 6 plus 2n pi. Again, that's a cosine and a sine, so their natural period is 2 pi. Okay. Now we've got square roots here. So notice that the variable is squared. So this is kind of like 3x squared minus 1 equals 0. I would add 1, I get 3x squared, and then divide by 3. And so x squared is going to equal 1/3. And when I take the square root, I get x equals plus or minus the square root of 1/3. Which is the square root of 1 over the square root of 3, which is 1 over the square root of 3, which is the square root of 3 over 3. So here, tangent of x is going to equal plus or minus the square root of 3 over 3. If I look at the unit circle, everywhere tangent has a positive or negative square root of 3 over 3 is all the pi over 6's here. All the pi over 6's. And the natural period for tangent is pi. So I'm going to take this pi over 6, and you'll notice that right here is pi. And then this one's going to be 5 pi over 6, and so it will also repeat another pi. So my equations would be pi over 6 plus n pi, and x equals 5 pi over 6 plus n pi, where n is an element of the integers. If I'm listing out all the angles between 0 and 360, then I would list out all 4 of these, 7 pi over 6 and 11 pi over 6. So the difference is, if I want all solutions, I list out the equations. If it's just saying from 0 to 2 pi, then I would list out all 4. Okay, for this next one, it's like 4x squared minus 3 equals 0. So I add 3 and I get 4x squared equals 3. divide by 4, and I get x squared equals 3/4. Then I take the square root, which is the square root of 3 over 2, and so x is equal to plus or minus the square root of 3 over 2. So this is a sine. Okay, so I want, my equation is that the sine of x is equal to plus or minus the square root of 3 over 2. Alright, so my unit circle, the square root of 3 over 2 is like almost 1 and almost negative 1 here. So these are going to be my pi over 3. So I got pi over 3, I got 2 pi over 3, I got 4 pi over 3, and 5 pi over 3. So if I had to list out all of the solutions, it would be that x equals pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. If I write them as all solutions, I can either do x equals pi over 3 plus 2n pi, x equals 2 pi over 3 plus 2n pi, x equals 4 pi over 3 plus 2n pi, okay, where n is an element of the integers. I could also say, well, if pi over 3 and 4 pi over 3 are both part of my solutions, then I could actually combine those and say x could equal pi over 3 plus n pi, because pi over 3 plus 3 pi over 3 is 4 pi over 3. I can also do the same with 2 pi over 3 and 5 pi over 3. And I could condense those to these. So either way, whether you list out all 4 or you figure out a way to condense those equations, I'll take either. All right, last one here. Solving 2 cosine squared x minus 1. So I'm going to add 1, and then I'm going to divide by 2. And so I get cosine squared x is equal to 1/2. Take the square root, and you end up with cosine of x is equal to plus or minus 1 over the square root of 2, which we know to be the square root of 2 over 2. Okay, so in fact, that's actually going to be all of our pi over 4s. So my solutions would be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now, each one of these are actually a quarter apart, so pi over 2. So I could write one equation. I could write all 4, or I could say pi over 4 plus pi over 2 times n, where n is an element of the integers. So again, these are just the solutions from 0 to 2 pi, and this would represent every single one of those places right there. Okay? All right.